first one. So we are supposed to find any critical numbers of this function. Hey, careful on that chair there. Like, you can use mine.
The last girl peed.
She did something over there. All right, so I need to take the derivative of this. All right, so when I take the derivative, well, first let's do a rewrite just so that it's easier to see. This is sine x squared plus cosine of x. So when I take the derivative of this, I'm going to get 2 sine of x to the first times the derivative of the inside, cosine of x, times the derivative of the very inside, which is 1, so we're okay there, plus the derivative of cosine. Okay, now what can I factor out here? Sine of x, leaving me behind with a 2 cosine of x minus 1. And now I need to figure out when each one of these things is 0. This one's going to be 0. Right? When is sine 0?
0.
At 0. Okay, but that one wasn't included. Pi over 2. So this one's out. How about 2 pi?
Yep.
That would also be 1, but also not included because there's no bars under here. So those two are out, even though that they are viable answers, but they didn't fit on my interval, so I can't use those. So I'm just using pi over 2. All right, and then for this one, I need to figure out when 2 cosine of x minus 1 equals 0. Well, that's going to be, if I add 1 to both sides,
That's just going to be,
and divide both sides by 2. So when is cosine of x 1/2? Right? Now, cosine is adjacent over hypotenuse. So what kind of triangle has an adjacent of 1 and a hypotenuse of 2?
30, 60, 90.
Now, it's going to be 30, 60, 90. Am I looking at 60-degree angles or 30-degree angles? 60s. Because my adjacent is the 1. That means it's got to be the short side. So it's got to be this way. 1, 2, square root of 3. So that's going to be a pi over 3. Now, where else is cosine positive?
In the second.
It would be negative there.
In the
Third.
Fourth quadrant. So that's going to be a pi over 3 and a negative pi over 3, otherwise known as 5 pi. I'm sorry. This is
5 pi over 3.
5 pi over 3. Okay, so these are all my critical numbers. Did they want the numbers or the points?
They want the numbers.
They wanted the numbers, so just the x parts. If they wanted the critical points, then I would take those and plug them back into the original and get my y's.
Yeah.
Okay, any other ones?
No.
Okay, let's take a look at what we're doing today.
No.
Okay, this is what we're going to do. I just picked out a couple from this section. You have this whole section to do. I've actually omitted, if you take a look at this assignment, we've got 19 through 34 all, but you don't have to do 31 or 32. We're going to do, wrong one, this guy, 20 and 28 together, so that's going to kind of cut down on what you got to do. But I want to take a look at these, make sure that we're doing them all right. And then 55 through 58 are a lot like the problems that I had yesterday, where we had the graphs and you had to come up with the absolute value, not the absolute value, the absolute maximum and minimums, and then also the relative maximums and minimums.
Super.
Alrighty, so let's take a look at number 20 first. So for this one, the directions just say that we are supposed to locate the absolute extrema of the function on this closed interval.
What if you fill that stuff up?
Okay. And actually, it's going to be easier if I don't. Because what can I do to this to make it, do a rewrite to make it easier to take the derivative of?
Times 3 to the negative first.
Oh, that's worse. How about I just break this up?
Break it up.
2/3 x plus 5/3. Now, take the derivative of it. I'm going to get 2/3.
Yeah.
I like that. Okay, so when is this thing going to equal 0?
That's,
What?
you plug it back in.
You plug at 0 because it's the derivative is death.
No.
When is this going to equal 0?
Oh, at the 2 halves, 2/3. You're gonna take it
And,
here.
Come on, let's think a little bit.
Okay.
Let's just not shout out things.
swag. No.
Whoop.
Whoop.
All right.
Okay, so Would you just plug it back in and solve? No? Okay.
People.
It's a
When will 2/3 be 0?
Never.
Never,
Sweet.
ever, ever,
We were just over.
ever. Okay, because now, let's think about this. What kind of picture is this?
It is a one.
Mine.
It's a line. So am I going to have a...
No.
No, it's not going to bottom out. It's not going to top out. I'm not going to have any of those critical points there. So that means that where will my absolute maximum and minimum be? At the end point. So basically, we just have to plug these guys in. So f of 0 is going to be 5/3. So I'll have the point 0, 5/3. And then when I plug 5 in there, I'm going to get 15/3, which is 5. So f of 5 is 5. So I get the point 5, 5. This is the max. This is the min.
Flag.
Oh, it's Sean Combs.
What?
What'd you say?
I said, oh, it's Sean Combs. P. Diddy, no swag. All right, so for this one, now this one I am going to have to quotient rule.
Yeah. So let's see.
All right, so we go low.
D5.
I think that's a 3.
It's a 2.
It's a 2.
It's a freeze.
It's a deuces.
So x squared plus 1. So low, d high is 2, plus high,
Low.
d low, all over, and this should be minus, not plus, all over the bottom, squared.
Yay.
Okay.
You cancel those out. No, you can't.
Not yet.
I wish you could.
I might. So I want to distribute here. I get 2x squared plus 2 minus 4x squared all over x squared plus 1 squared. All right.
Pull the 2 out. Pull 2x squared out. Pull the 2 out.
Well, I can put these two together. So I'm going to get 2 minus 2x squared over x squared plus 1 squared.
Pull the 2 out.
Pull the 2 out, leaving me behind with 1 minus x squared over x squared plus 1 squared. Can I cancel one of these? Are these the same? No. Okay, but critical numbers.
Fine.
That's going to be where the top is 0 or the bottom is 0. What numbers are going to make that happen?
1
1,
and
negative 1. Can I get the bottom to be 0?
yeah,
No, actually. So I'm okay there. So these are going to be my two critical numbers, so I need to figure out it's 1 something, negative 1 something. What else do I need to test?
the endpoints.
So negative 2 something and 2 something. I should probably put these in numerical order. So let's go negative 1 here and 1 there. All right, so let's start plugging these things in back into the original. So it was 2x over x squared plus 1. If I plug in a negative 2, I'm going to get negative 4 over 4 plus 1, which is 5, so negative 4/5. Negative 4/5. All right, if I plug in my negative 1, I'm going to get negative 2 over 2. That's negative 1.
Sweet.
All right, if I plug in my 1, I'm going to get 2 over 2. I get a positive 1. And I'm going to get a positive 4/5. So which one is my absolute max?
2.
Which one got me up the highest here?
The last one to come with 4.
Nope.
No. 1.
This one. So this one's my absolute max. And my absolute min? Absolute min. Good. All right, think you can handle those?
I think we can.
Wow.
And then the other one's looking at pictures.
Okay.
Aren't you glad I sent you that picture last year?
Yep. All Olivia's answers.
Yes. Not included.
We're throwing